So January 23, Unit 5, we'll discuss the MCQs. So the first question, a student use a detector and a counter to measure a background counts for 5 minutes. He used this value to calculate the background count rate. Which of the following would increase the accuracy of the student's value of the background count? Like if you want to increase the accuracy of the result, what we should do? Decrease the count time to 1 minute. Look, as we just discussed now, Unit 6, that if we collect more results, we'll be more certain about our results. So we'll have lower uncertainty or greater accuracy. So he recorded for 5 minutes the count, decrease the count time to 1 minute. Means record only, like he recorded for 5 minutes, but instead of 5 minutes, he should record only for 1 minute. If he record for 1 minute, he will have less result. So that will give a higher uncertainty. Increasing a count time to 10 minutes, if he increase the count time to 10 minutes, like he's recording for a longer duration of a time, so as a result, he will be more certain of his answer, like what is the background. So B will be the right answer. Repeating the count with different detector and calculate the mean. If we repeat the experiment, it will not, because what will happen, accuracy of the result, like it will not affect the uncertainty. As we are doing this will not change the accuracy of the result. As we did not change, we just change the detector, a different detector is used, and we calculated the mean and average. And same thing, the results are the same, that's why it won't affect the. And we are repeating what with a different detector. Like different types of detectors are there. So, and repeating a count in a different location and calculating a mean. So if we repeat a different location, the background count changes from place to place. Like some places we'll have a higher background counts as compared to other places. So it won't be accurate method, as we want to increase the accuracy of the results. So if whenever you want to increase the accuracy of the result, what you should do? You should collect more results, like doing it, even this one is done, repeat the count, but with a different detector and calculating a mean. So we should use the same type of detector and calculate the mean. Question 2. A cylinder contains a mixture of gas X and Y. The mean kinetic energy of molecule of X and mean kinetic energy of Y is EY. The molecule of a gas X is twice as molecules of Y. Which is correct? So their mean kinetic energy means half mv square. So we want to compare the results. As I mentioned here, the mean kinetic energy is equals to half mv square. So Ex and Ey. And the cylinder, it's a mixture of the gas X and Y. So means you have X and you have Y in the same container. When two gases are in the same container, definitely they will have the same temperature, because the temperature of the gas is the proportional to the kinetic energy. Higher the temperature, greater the kinetic energy. So it means if they're in the same container, they should have a same temperature. They did not specify, but it should be have a same temperature. Like it's a mixture of the gases, so the mixture should have a same temperature. And the temperature affects the kinetic energy. So if they have the same temperature, they will have the same kinetic energy. So means the kinetic energy of X and the kinetic energy of Y should be same. The mass is different, the velocities will be different, but the kinetic energy will be same, because kinetic energy is half mv square So for X, as I mentioned, the molecule of X has a twice mass. So if the molecule of the X is having a twice mass, like they are 2m, so their velocity will be lower. Their velocity will be less. And the molecule of a Y are lighter, so they will move at a high speed. But the kinetic energy of X and Y should be same because they are mixed together and they are in the same container. So the temperature of the container should be same. That's why the kinetic energy should also be same. Speeds will be different for the two molecules. I'm not saying speed is same. Speed will be different, but the kinetic energy will be same. Fusion of a nuclei of iron in a star does not release energy. So when iron is there, it undergo, look, if you remember the binding energy per nucleon graph, this is a graph. The peak is occupied by iron. Whenever the binding energy per nucleon increases, the reaction is exothermic. If the binding energy, when one atom changes to another atom, and the binding energy per nucleon increase, the reaction will be exothermic. So what could be the reason why it does not release any energy? But if the binding energy per nucleon decreases, it means the reaction will be endothermic, like it has to take in energy. So which one it match with? The magnitude of a nuclear binding energy is least for no. The magnitude of nuclear binding energy is greatest for iron, Fe plus 6. It's not binding energy. This graph is not only binding energy, this is binding energy per nucleon. So why this is wrong? Binding energy is for the total. Binding energy depends on the number of the nucleon. But this graph which we have is a binding energy per nucleon. Like for iron, it is about 8.8 mega electron volt. Means we need about 8.8 mega electron volt to remove one nucleon from the iron. Iron is having the highest binding energy. Total binding energy depends on binding energy per nucleon multiplied by number of the nucleons. But this graph is for binding energy per nucleon. So binding energy per nucleon is least for iron. No, it is maximum for iron. So D will be the right answer. So always remember when binding energy per nucleon increase, the reaction will be exothermic. If it decrease, the reaction will be endo. That's why fission and fusion, both cases, when a lighter nuclei undergo a fusion and the heavy nucleus, when heavy nucleus undergo fission, both are exothermic reactions because binding energy per nucleon increases. A student measure a temperature of 0.015 kilogram of a wax as it cooled and changed its state from a liquid to solid. The energy was transferred from wax to the surrounding at a rate of 25 watt. The temperature of the wax varied with the time, T shown. Which of the following shows a specific latent heat capacity? Specific latent heat means amount of energy required to change the state of a 1 kilogram solid into liquid or a liquid into gas. So latent heat is energy divided by mass. And energy is power multiplied by time. So power into time divided by mass. Power is 25. Duration for which it is changing the state from 50 to 150, so that is 100. And what about the mass? The mass is 0.015. So 25 into 100 divided by 0.015. So it matches with option A. Because the latent heat is, whenever there is a latent heat, the temperature does not change. So because it's the energy needed to change the state. The absorption line spectrum of a light from a star is shifted to a higher frequency. So we are observing any star and we observe, like in the lab, let's say it should give out a frequency of 200 hertz, but it is giving out more than 200 hertz. So what this give an indication? This give an indication that the star is moving towards us. Which of the following can be concluded? Because if the frequency increase, it is moving towards. If the frequency decrease, it's moving away. So the star is moving towards the earth. The star is accelerating away, like here also, star is accelerating. If the star was accelerating, then we should shift it to a higher frequency, and the frequency should also change. Because if it is accelerating, acceleration is there, so that the frequency, the shifting of a higher towards a higher frequency also continuously change. Like first it is, let's 220, then 250, then 270, because it is accelerating. So greater the acceleration, greater the change in the frequency will observe. Because in the statement they did not specify that the frequencies, it's only mentioned shifted to higher frequency, but they did not specify that it's continuously switching to higher frequency. Then we will use the term it is accelerating. Is it clear? In question 6, the nucleus of americium emits an alpha particle that releases 5.64 mega electron volt. Which of the following expression give the decrease in mass? So we have the energy. We can use a formula like how a mass in kilogram is equals to mc square. Okay. I need mass. So energy divided by c square will be equals to mass. But this energy is in mega electron volt. I have to convert into joules first. So mega electron volt into electron volt. So this will become 5.64 exponent 6. And then electron volt into joule, then it will be multiplied by 1.6. So this will be multiplied by 10 power 6, and this will be multiplied by 1.6 exponent minus 19. So 5.64 into 10 power 6 times 1.6 into 10 power minus 19. That will give us energy in joules. This was in electron volt. And then energy in joules divided by speed of a light. So 5.64 into 10 powers. This 6 and 19. So this will become minus 13. So 1.6 exponent minus 13 divided by the speed of a light, which is 3 into 10 power 8, and then square. This will give us the mass in kilogram when we simplify. So A will be the right answer for this. Next question is, a student investigate the absorption of gamma radiation by a lead, but like didn't they ask to decrease in? Yeah, decrease in mass is how much mass decreases amount of energy which is released. So we use a formula E is equals to delta mc square. So how much energy is released by, in terms, the nucleus of americium emit alpha particle of energy release is 5 points. So this energy released by the alpha particle, which of the following give the mass decrease in mass in kilogram for a nucleus that emit an alpha particle? Yes, we should also do that as well. But according to the energy, we just have to calculate how much energy released. Definitely, the alpha particle is there, which is emitted. As you can see, when a nucleus of americium emits alpha particle, the energy release is this much. So this energy release, they included everything, including like if the alpha particle is a matter, but alpha particle mass, which is converting to energy, plus the total. So it include all, like in the question. The question is, which of the expression give a decrease in mass for a nucleus when it emit alpha particle? The nucleus release this much energy, which include the mass of alpha particle. Like this 5.64 mega electron volt included the energy associated with the mass of alpha particle. That's how we worked out. And none of the expression was mass of alpha particle was subtracted. The next question 7. The student investigate the absorption of a gamma radiation by lead with no absorber. The intensity is I naught. When a thickness is 0.8, it is 0.25. What is the thickness of absorption would be? Would give the intensity half. So point A, look, if it is I naught, half will be I naught by 2, and this will be a quarter. Means 0.25 is a quarter. So quarter is due to 8 centimeter. So half will be due to 4 centimeter. Means 0.4, I mean, not this, because this is 0.8. So half will be 0.4 centimeter. Like when nothing is placed between, and when we place like intensity decreases to 0.25 or quarter of the original, when 0.8 millimeter thick absorber is placed. So the question is, what will the intensity when we'll get the half intensity? So half intensity will be like when it is about 0.4, half of the double of this original. So we'll get the, because the intensity and the thickness are inversely proportional. Is it clear, this question 7? Then in question 8, we have the Hertzsprung-Russell diagram. W, X, Y, and Z shows a cluster of stars in various time when the cluster is different stages evolve. Which diagram of a cluster final stage of evolution? Which of the diagram represent the cluster in the final stage? Look, as you can see, this is a HR Hertzsprung and Russell diagram. In the final stage, we will not have any red giants will not be there. Like we will not have, because in the final stage and the various of star and evolution is there. So in the final stage of this, we will have the white dwarfs will be there, and Hertzsprung Russell diagram. It's for low mass star, high mass star we don't find because you cannot plot a black hole here. So this is a case. W are there white dwarfs, star, and a red giant in a cluster. Why W is not correct? Because at the end we won't have a red giants, because red giants will evolve. X, as there are red giants and no white dwarfs, no way it will not be in the X. There are red giant but no white dwarf, but that is not the final stage of evolution. In a final stage of evolution, we should have a white dwarfs. Why there are white dwarfs but no red giant? Yeah, that's right, because when there are no red giant, because at the final stage of evolution, we'll have white dwarfs, not the red giants. Like, or most of the stars will turn into a white dwarf at the final evolution. And what about Z? All the stars in a cluster are in the main sequence, but that is not happening. That is in the beginning. In the beginning, it will be like this. Then this is what happened. Then this is actually, if I list them, this is the first stage. What will happen? We'll have a main sequence. Then some of the main sequence will turn into a red giant. Then some of the red giant will turn into a white dwarf. And at the evolution, like when the star is about to evolve, the most of the red giant will turn into a white dwarf. So this low mass star, because why the low mass star still remain there? Because they have a longer main sequence lifespan. So this is how the order is there. 1, 2, 3, 4. That's then an object oscillate in a simple harmonic. The period of oscillation is 0.65. Amplitude is 0.12. Which of the following maximum velocity? Maximum velocity A is equals to V is equals to omega A. That's a formula for maximum velocity. And omega is 2 pi F. So in place of omega, I can write 2 pi f, and f is 1 over t. So I can say A is 2 pi over t. So A is the amplitude 0.12. So 0.12 is the amplitude. So 0.12 is the amplitude multiplied by 2 multiplied by 3.14 divided by time 0.65. So which one it matches with? It matches with option B. Then in a simple harmonic, which of the following velocity graph? Look, if remember the graph, like example, if a displacement graph is a, first, what is this graph? This is a sine graph, sine theta. So we have x, v, and a, because this is representing a sine theta graph. So if, and what is the displacement? Displacement is always opposite, like inverse. So it will be minus sign. And what is the derivative of a minus sign? The minus sign is cosine. So like this will become cosine theta. So the graph will be the cosine theta graph for the display velocity. So which one is representing a cosine theta, like negative cosine theta graph? Because derivative of a sine is cosine and this negative sign is there. So which is a negative cosine theta graph? That will be B.